Welcome back to the show that tells you you are a quantum computer with free will, collapsing the wave function to participate in the universe. My name is Justin Riddle, and this is episode 38 of the Quantum Consciousness series. In today's episode, we'll be laying out some arguments in favor of a single universe and against the multiverse. By the end of today's episode, we'll ask the question, is there some meaningful computation underlying the flow of time that could explain a non-random Big Bang at the start of the universe? This episode is available on YouTube, and an audio-only version is available on Spotify and Apple Podcast. If you like what you hear today, then please like this video, subscribe to this channel, leave a comment below, or for the audio listener, write a review.
Join me deep inside the mystery of numbers. Come and huff a metaphysical new. See how concepts become objects and then become qualia. Join us for an episode of Quantum Consciousness.
All right, let's dive into the multiverse. So the layout of the episode today is I will be setting up a little bit of background on why people believe in a multiverse. This really arose from quantum mechanics and from the evolution of the superposition, which we'll talk about. I will be talking about the challenges associated with asserting a single universe. In a way, you're forced to dive down, the murky rabbit hole that is Roger Penrose and Stuart Hameroff and some of these theories that are kind of considered outside of mainstream science. So I'll, talk a little bit about why that is the case. Next, I will be talking about why the multiverse is computationally not a very satisfying theory. And while it sounds great, at first exposure or at first pass, solutions that rely on random chance and rely on this kind of multiplicity really don't cut it when it comes to computer science and designing algorithms. So I'll be framing the multiverse algorithmically and expressing some of its shortcomings. Fourth, I will be talking about the concept of the Big Bang, which appears to be somewhat tied in with this question of the multiverse. So we'll be talking about alternatives to believing in this sort of strict Big Bang theory, namely Roger Penrose's conformal cyclic cosmology, which asserts that there are multiple eons of the universe evolving from one to the next. And I'll also briefly comment on Ray Kurzweil's The Singularity, which seems to be tied in at least to some degree with this previous idea. And then finally, I'm going to end on sort of the element of meaning, right? The sense of being a person, making choices that matter, and why the universe is really essential to our sense of purpose, our sense of vitality, and our connection to the here and the now, and to sort of the responsibility we have on this planet in our lifetimes. And while this is sort of a, implication of the conversation, I think it's still really important to sort of touch on the sort of human element to why the multiverse matters, and why it's sort of dehumanizing, essentially. All right, to start off, I'm going to give a brief primer on quantum mechanics at a very high level. So in essence, the basic components of reality are we have these quantum systems, these simplest units of reality, photons, electrons, atoms, what have you. And the nature that is given to us in quantum mechanics is what's called unitary evolution, or the evolution of the wave function as given to us by the Schrödinger equation. And essentially what this says is that any piece of matter, any sort of quantum system in the universe is going to evolve into a superposition of all possible future realities for that system, right? So a photon, often depicted as a light cone, these are all the possible directions that the photon could move in. And the light cone represents sort of a reduction of 3D space into 2D space, depicting time as one of those dimensions. And the photon could evolve out into any of these locations in a sphere, let's say, right? It could go in any direction. So the photon exists as a superposition of all of these possible realities simultaneously. And this is sort of the curious, weird thing that quantum mechanics gives us, right? And so the tricky part is that when you observe the photon, when you measure the photon, you find that, okay, while it evolved into all these possibilities, when I look to see where it is, it's going to tell me I am here or I am there. It will end up in one possible location of the superposition of many possible realities that it could have been in, right? And so what's weird here is that the introduction of a measurement device, a collapse of the wave function, presumably occurs, where it was in all these possible realities, but upon measurement, it ended up here or there, and it's no longer in this sort of multiplicity of states, right? It's no longer in superposition. So quantum mechanics suggests that there's sort of this duality within nature. There is the evolution of the wave function and then the collapse of the wave function to a definitive state here or there, right? And this evolution and collapse are sort of taking place one after another. And this is a very bizarre way to frame reality, right? We are very uncomfortable with dualism, with dualities in nature. We want to say that really there's just one process governing reality. We don't want it to be the case that there is this measurement device and when it gets applied and what constitutes a measuring device. But this measuring device is applied, it changes the system irrevocably. It was evolving, and this is a deterministic evolution where you can really lay out, what state it's going to be in and what the probabilities of all these different states are. And now we're throwing in this wrench into the system, this measurement device that changes the system. It can never get reverted back. It can never go back to the way it was. The system is changed through measurement, okay? That change is unsettling. It's weird, and we wish that the universe was deterministic in a sort of first order, simple sense, right? If everything could be determined by its prior state, that would be great. We want to live in a universe, I guess the impulse here is that it's more simple, it's understandable fundamentally on some level, where everything can be determined from its immediate past, right? There's some set of causes in the immediate past, and then you can derive what the present moment looks like, right? Intuitively, we, assume that this is what physics gives us, this is what science gives us. We must live in a deterministic universe, right? And so the tricky part is that the measurement collapses and changes that determinism, and it appears to be non-deterministic. It is a probabilistic jump. It is a cut in determinism. It is a break in determinism. And this is not what many people desire the world to be. And so there is a push to remove the collapse of the wave function from quantum mechanics, from physics. The push is, how do we not have this non-deterministic step? We don't want this dualistic, deterministic part, non-deterministic part. We just want the single description mathematically of how things operate, and we want it to be deterministic because we have some intuition/bias, my own opinion there, some intuition/bias that everything must be deterministic, everything must be determined, everything must have a cause from the immediate past, right? So the multiverse, here we are talking about the multiverse. The multiverse is essentially a way to say that the evolution of the wave function into multiple possible states is objectively real. This really actually happens where the universe is splitting off into a multiplicity of all these different possible options. So when the photon evolves out into the light cone, right, which is really a sphere of all possible futures for the photon to move in, when it moves out like that, each of those movements is a different universe. So we live in a multiverse where all of these possibilities of this photon's future all are occurring. You can't see them, they're all around us, but they're constantly splitting off everywhere around us, right? This is a way of saying, forget about collapse of the wave function. Collapse of the wave function is somehow our misunderstanding of what is taking place in reality. Something's off with our conceptualization of that. We need to reconceptualize that collapse out of physics, and we're going to replace it instead with this evolution of the multiverse where every single atom, photon, electron is splitting off into many, many multiverses at every possible nanosecond, right? This is an absurd amount of multiverse splitting to a degree that the mind is boggled. The mind cannot fathom or comprehend the degree to which this multiverse splitting is taking place, okay? To reference where this comes from in history, Hugh Everett is really one of the proponents of the multiverse. At its core, the multiverse is an embrace of determinism and a rejection of the collapse of the wave function. And so, strangely, this has somewhat become status quo reality in what I would call mainstream science or mainstream physics, right? And we see this, all around us. If you look at, some of these pop science figures like Neil deGrasse Tyson, Bill Nye, a lot of these people just kind of espouse the idea of the multiverse as if, hey, this is what everyone agrees upon. This is how it works. This is how it goes. There's sort of this mainstream science push on some way to just say, hey, don't worry about science. We got it all figured out. Physics, we got it in the bag. This is all pretty known to us. We're just, crossing the T's, dotting the I's, but we've more or less, mapped out what science is all about. And what it tells us is there's a multiverse and you can't see it out there. It's sort of beyond measurement, beyond our ability to comprehend or to know of its existence. But let's just say it's all happening and this is kind of, what the world gives us. You see it in movies and TV, right? So like the Marvel Cinematic Universe has gone full multiverse where it's just kind of embraced this idea and kind of pitches this as like, yes, this is what science tells us. There's a multiverse out there, haha, and we're going to pop around between different branches of the multiverse, so forth, and so on. And so to counteract the multiverse or to not believe in the multiverse is in essence to believe in the collapse of the wave function, right? And this is somewhat a unpopular black sheep opinion. You have proponents like Roger Penrose and Stuart Hameroff, which have recently been gaining more traction in the science community to some degree. But all in all, these collapse of the wave function theories are sort of maligned, pushed off to the side, generally considered, new age woo-woo garbage to some degree. I, of course, believe this is a unfair label and association that has been put upon the collapse of the wave function theories. But in essence, you would have to believe in the collapse of the wave function that the superposition does not represent the multiverse, but instead it does in fact represent a probability space. These are possibilities. They're not real in the sense that they've forked off from reality completely. The different possibilities are in fact very real in and of themselves. So for example, in the double slit experiment, you have the photon splits off into the two slits. We can imagine these are different parallel universes, right? Or different possibility spaces. And then they actually interact with each other. So these different possibility spaces actually do sort of smash into each other, interact very dynamically. And a lot of the, power of quantum computers, of quantum algorithms, is derived from the fact that these possible spaces are actually still interacting with each other until you perform the measurement. They're alive and well and interacting, and then upon measurement, then you get the collapse and reduction. So the alternative to multiverse is to say, these are possibility spaces. These are possibilities that really do exist, and then the measurement creates a reduction in the wave function, right? And so the alternative of taking the superposition to be objectively real as a multiverse is to say that no, there's only a single universe, and these superpositions are probability spaces. It's multiverse-esque in the sense that, yeah, they really are splitting off and they really are there. We do have kind of a multiverse-like phenomenon in reality, and yet they're interacting with each other. But then when you make a measurement, you destroy those other possible universes. They are gone. They have been deleted. That is an act of destruction where you cannot recover those different parallel universes that might have split off, right? So this is a much more nuanced view on how, the universe works. There's multiverse-like qualities, but really the collapse moment is very real and creates a huge change in the system. The collapse of the wave function is objectively real. And, there's a lot of issues on, what is a measuring device, what constitutes measurement. This is a whole other can of worms that I'm not going to go into in this exact moment. But let's move on to the next topic. So algorithms, right? A couple arguments in favor of the universe. One of them is through quantum computation. In the very near future, we will have quantum computers. We will be running quantum algorithms. They'll be in your homes, or they'll at least be in centralized servers that you can access via the internet. And when we're thinking about quantum algorithms, we have to think about these algorithms in this sort of probability space, collapse, get an output. And I think we're very soon going to enter into this information age where we go from digital information into quantum information. And the quantum information age is going to very intuitively drive home the concept of measurement, the input and output of the quantum computer, the sort of sacred space of quantum evolution between measurements, and how your quantum computer needs to evolve. It needs to generate this probability space, this pseudo multiverse, and then it's going to get collapsed and you're going to get one output from that computer. And so we will be thinking about quantum algorithms in this very specific way, where the idea that, within every quantum computation, there's this branching off of multiverses that then exist independently. I think it will just feel excessive and unnecessary. Why would all these different possible, kind of bad, crappy computations of low probability, I'm trying to search a space and generate the correct answer. The correct answer is going to be this bolstered probability for that option, and then all the bad answers are going to be lower probability options. I want my quantum computer to give me the best possible output. That is the answer I want my quantum computer to collapse into. And so, taking that algorithm, that superposition as objectively real, where all the possible options of my quantum computation are different universes that are splitting off in this multiverse, bubble network of multiverses, it kind of just defeats the point of the quantum computation, right? I want to get the right answer. I want the quantum computation to run effectively and give me the best possible solution. Who cares about all the kind of bad computational options that are getting shot out just by virtue of that's a possible answer, right? So quantum computation gives us a framing of harnessing the universe computationally to do something productive. I want to evolve the wave function meaningfully and get the right answer. And then when I collapse the wave function, that's my output. This is an important output that I'm receiving from my computer. I really don't care about all the bad answers that could have been, that might have been. And then to obsess over all those different subspaces of poor solutions just seems to be missing the mark of the magic of the quantum computer, right? The value of the quantum computer is that it's running this computational process and bolstering some possibilities at the exclusion of others. And that is what is meaningful. And how is that mapped into the multiverse? Well, some of the multiverse arms, some of the universes that spawn within the multiverse, some of those are more stable. Some of them have better answers than the other ones. And it's just kind of this weird throwaway form of computation where let's just throw random nonsense at the system, and then one of those multiverses will pan out, and that will be the one that we're in. We just happen to be in like the universe that happened to have worked out. But that is just not really a computationally effective solution. So my next point here is about combinatorics. Combinatorics is the idea that we're looking at different patterns of combinations that we can make, right? So a good example is you take a deck of cards and you shuffle the deck of cards and you get a certain sequence of cards, right? And the question is, if I shuffle the deck again, what is the probability that I will get the same exact pattern of cards in the deck of cards? And now, if you've never heard this before, maybe pause and think about this for a second. How likely do you think it would be that you get the same deck of cards again? And the answer may shock you. It is 52 times 51 times 50 times 49. This is called 52 factorial. You just multiply all those numbers together all the way down to 1. And what you get is a very large number, 10 to the 67th power. This is a huge, huge number, okay? And what this number means is that we have probably never in the history of the planet shuffled a deck of cards and gotten the same pattern twice. That is mind-blowing, okay? Just with 52 components, 52 cards in a random sequence, you will never get the same pattern of cards twice, right? That is wild, okay? There are way more patterns of this deck of cards, a simple standard 52 card deck of cards, more patterns that you could set that up in than there are atoms in the planet. So if you take the planet Earth, you add up all the atoms, there are way more patterns of decks of cards than there are atoms in the planet. This is wild, okay? Humans are terrible at thinking about combinatorics. If you start caring about the sequencing, the patterning of things in the universe, then you get these massive values that come out, okay? What this means is that you cannot randomly type out Hamlet, if you just had random sequences of letters and you're trying to make a Shakespeare play like Hamlet, the chances that you will just randomly get a Shakespeare play are so vastly impossible that you can't even get the first page of Hamlet if you were typing at, gigahertz rates until the end of the universe, okay? I mean, these are like wild values. So what I also think is a massive shortcoming of the multiverse thought pattern, or the reliance on the concept of the multiverse, is you say, well, it's just going to be all this random stuff that happens, and then every now and then, oh my gosh, look, like something very magical and amazing happened coincidentally. Like the basic fundamental force of the universe is random chance. And then we just kind of randomly happen to be here. Huzzah, we have arisen out of chaos through random chance. This is so wildly impossible that it's hard to grapple with just how impossible this is. And I think if you are a computer science, person, or you've programmed in your life, you've seen just how finicky a digital computer is. If you type something in wrong, if something isn't perfectly right, everything collapses and falls apart. So the idea that we are going to assemble the universe that we live in off of random chance, off of chaos, is just so far from how things are likely working. And I think this really hits home in combinatorics, in really visualizing just how improbable everything around you is if it is supposed to arise from chaos. And at the core of the multiverse is this notion of chaos that, you just do everything randomly, and then the universes that work out, well, hey, that's great, they work out, and then everything comes from that process, right? You just do everything randomly, and then the one that works. And here we are in this branch of the multiverse where everything just happened to work out, and that explains why we're here. But then at every single possible moment, we're going to be destroyed in the multiverse because chaos should ensue, and we would just self-collapse and destroy ourselves entirely at fundamental atomic photon scales, right? I mean, the level of chaos that must be at play if the multiverse is the saving grace of how things happen, that you just do everything randomly and then it just happens to work out. We would not be here. We would be destroyed. I would be talking to a destroyed universe as we speak. And then you say, well, but we just happen to be in the arm that worked out, and it's going to probably keep working out because we're still here. Fair. Like there's not like a strict argument against that, because it's kind of like outside of the realm of what you could even test. But it seems like a bad solution, and it seems like it's going to run into problems, and that brand of thinking is not going to build quantum computers and advance technology and medicine to the future. So I think we will prove to ourselves, through quantum computation and through expanded understanding of our place in the universe and of how things work, that there's more to it than just a bunch of random chance and then things work out. Okay, a couple final points here, just kind of by extension, right? So a few implications of rejecting the multiverse in favor of the universe. Let's think about the Big Bang, okay? So I'm not like a super expert in the Big Bang, but essentially the way that a lot of people think about this is that, we won the cosmic lottery, okay? Wow, we just happen to have the gravitational constant and Planck's constant and the speed of light. Everything just seemed to just work out, right? Wow, great. The universe is here. The Big Bang occurred because we just lucked out and we just happened to be in one of the branches of the multiverse where the fundamental constants and laws of physics are conducive to the creation of the universe, and they're conducive to the evolution of life and matter and fusion in stars and all of this great stuff that keeps us alive and keeps things going, right? This is a very similar argument to the multiverse argument. Hey, we just happened to be here. Everything worked out great. It's all random chance. Like, go live your life. You're just a bunch of random forces and then you die, right? That's kind of the status quo thinking of the multiverse. Terence McKenna had a really great quote in regards to the Big Bang, where he says, "This is the ultimate test in credulity. Will you take at face value that there was nothing and then there became something for no reason whatsoever, just randomly? There was nothing, then there's something, there's no purpose, no reason. Just let us just have everything get created out of nothing for no reason," right? And Terence McKenna basically says, this is absurd. If you think about it, it is absurd that this is kind of like the standard status quo of how we think the universe began. The Big Bang was actually termed by someone making fun of how ridiculous it sounds and how ridiculous it is. And yet now this is sort of, this insult that was leveled against Big Bang Theory is now just taken as, the scientific term for the Big Bang. So, I'm not denying that, we came from this cosmic microwave background that we can see evidence of. And, there's more to it. But coming back to this universe multiverse question, the alternative is that the constants, reality itself, the basic laws of physics are somehow more intrinsic to what is occurring, or somehow was meaningfully generated or created in some way, shape, or form, right? So Roger Penrose, coming back once more, he has this idea of conformal cyclic cosmology, basically saying that before the Big Bang, there was another universe. And before that universe, there was yet again another universe. And after our universe, there will be a future universe. He refers to these as eons. And he talks about, the previous universe kind of sets up the next universe. And so this is a very non-chaotic description or explanation for how we got here. It is kind of not answering the question, but it's just kind of kicking the can down the road to a previous universe to have come about. But essentially it's saying that there is no lottery system, okay? There is no such thing as a cosmic lottery. If we look at quantum mechanics and quantum systems, they may be quantum computing. The evolution may not just be random, and the collapse may not just be random. It might be chaotically collapsing to some sense, but the probability distribution is meaningfully generated. It represents the result of a computation that has been run. And so what if time itself, what if the evolution of systems in the universe is meaningfully computing into the future, and this extends back into the past, extends into the future, and this is a universe, right? Within viewing the universe as a single universe, these computations are meaningfully happening. There might be some chaotic forces, right? But it's not just pure chaos. There's some sort of computational element to the evolution. And so it was not a lottery system that explains why the universe has all the constants that it happens to have, but instead, there was some evolution that led to that point. The universe is growing, it is evolving in some way, and so those constants were given from the previous universe. Where did that universe get its constants? From the previous one, from the previous one, from the previous one. Maybe these are changing. Did that all have to start at some point? I don't know. But this is sort of a more eternal view of the universe. And who knows what's at the end, right? Like when we start talking about the universe at this scale, really all bets are off when you kind of get to that level of magnitude. One more aside here is with reference to Ray Kurzweil's The Singularity is Near. So in The Singularity is Near, Ray Kurzweil makes the proposal that we are building technology, and our technology through digital computers, through coming quantum computers, are an extension of human evolution, that biology has created some computational drive. We are now reverse engineering the forces of biology, the forces of consciousness. We will merge with machines. We will become super intelligences that are like part robot, part human, part biology mixed with tech. But on a grander scale, he says that we will infuse the universe with consciousness, with awareness, and the future holds a point where we have sort of terraformed or consciousness formed the universe at such a grand scale that at some point maybe we envelop the universe with life, with consciousness, and then we transform the universe, and that becomes the next stage of the universe. And we are actively approaching a Big Bang through technology in the future, where it's more of a technological upgrade to reality rather than just a restart, right? So it might not be like a destroy and rebuild. Potentially that's how it works. But some people like Ray Kurzweil are kind of pitching this idea that we will build towards potentially a new universe, right? And maybe that happened before our universe, where there was some sort of evolution, and then it gave rise to what the current universe holds and, the current state of affairs, right? Where we've been here 14 billion years and, we've been on the planet for less time than that. But, viewing the world at this more grander scale, where there's more than just random chance, there's some sort of meaningful force of evolution that is not just randomness and not just driven by chaos. All right, so I'm going to close on some thoughts about the universe from an experiential standpoint. So it is my conviction, and in this series, I've talked about free will. I've talked about a sense of self, or the concept of like a soul in some ways. And I've made arguments in favor of free will, in favor of you really existing, which, hilariously in modern science, you have to argue that your choices matter, that you actually exist, that we're really here right now, that time exists, and that the present moment is where we are currently. We don't have a strong basis for a lot of these concepts in deterministic physics that denies the collapse of the wave function, right? So I think the universe is very much in line with this sort of more human view of reality, where you exist, your choices matter, the universe is unfolding, you are participating in the one universe that we are in. And I think it's tempting to dive into multiverse thinking and say, I'm not real. I'm just a chemical, genetic combination, electrical forces in my brain. I don't really make any choices. I'm just along for the ride. I actually don't exist. None of my choices matter. Nothing is really meaningful because everything is random and chaotic. And so I think the multiverse fits very nicely within the denial of free will, denial of self, denial of meaning and purpose, and in line with sort of shifting the script and saying, quantum computers, quantum mechanics gives us maybe a way that there could be a self, gives us the collapse of the wave function where your mind could maybe influence the physical world. Free will might take place in some sense through the non-deterministic break in the evolution of the wave function. And then the multiverse. We don't need to dive into meaninglessness. We don't need to dive into randomness. We could have potentially a universe, laws of physics, some sort of structure of meaning, maybe some Platonic forms, some truth, some purpose to the universe. We are playing a role in the evolution of the universe. And this is really happening, right? You are actually participating in the universe by making choices, by thinking, by connecting, by talking with people. And you change the universe. You change the course of history. This is sort of naive realism. This is naively how we viewed reality before we got wrapped up in our models thinking about, we have to make sure that the superposition is objectively real and now is a multiverse. And oh gosh, how do we make sense of all this chemical, electrical stuff in the brain? There must not be a single self in there because we can't find it, right? There's a lot of these sort of emergent frameworks through sort of new atheism or new sciencism that has kind of emerged. And I think the multiverse is sort of another tenet of that science-ism, where to assert that we live in a universe, suddenly you're kind of in that other camp. You're kind of outside of mainstream science to some degree. I hope you enjoyed exploring these ideas with me. I think this is a really fascinating topic. I find multiverse theory very, narratively weak when it shows up in media. I think it's very personally unfulfilling, and I think there's a little bit more to the drama of life if we live in a universe. So with that, I will talk to you later.